Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 22nd. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale previously in the Gulf that generated up to 40-foot seas. The remnant seas are pushing into the Pacific Northwest on down into California. Significant swell did result, but it is starting to dissipate. Also of interest, a tropical system, Typhoon Lan, about ready to impact Japan, but then is forecast to make a recurve to the northeast and turn extratropical. More on that in a moment. Let's get into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough that is a dip in the jet, just like this right here. Good winds blowing into that. It was at 1, 2, 3, 4 contour levels in the purple. 170 knot winds pushing into the trough, and an almost equal amount of winds pushing out of it. That would, at the upper levels, help support the formation of low pressure, counterclockwise circulation, both there and down at the surface. And of course, low pressure generates winds, winds generate seas. Seas, when they radiate away from the fetch area, generate swell, and swell, when it impacts your beach, produces surf. So let's see how this is to play out. Now the trough quickly pinches off come Monday, building still with 190 knot winds feeding into it, but pinch troughs do nothing really. They need some gap in there, some room to circulate, and that's not good. That probably will not do much to support gale formation, but notice it comes very close to Hawaii. That in and of itself might be able to generate wind swell for the Hawaiian Islands. So what you have is a ridge here, a giant ridge off of California. That supports clockwise flow circulation underneath it. That is the signature of high pressure, and normally in the center of high pressure things are very calm. So maybe a calm spot there, some sort of activity right in here come Monday night. Anyway, roll this out. Now here we go, another sort of a trough trying to get organized off Kamchatka come Tuesday, while the pinch trough actually cuts off completely and forms a closed low. There we go. Decent trough, 1, 2, 3. That is 160 knot winds feeding that trough, building to 170 or 80 knots come Wednesday and dipping out nicely, then starting to absorb the energy from the cutoff low north of Hawaii, and the whole thing just kind of dies. The ridge holds tight over California, meaning probably no precipitation, no swell generation, and hopefully light winds near shore. Anyway, back to the west. Another trough tries to develop come Friday. Not a lot of upper level wind support for it. What is that? Maybe 120, 130 knot winds or so. They're building a little bit more as we get into Sunday. Close, and there you go. Even more winds, 190 knot winds starting to feed it. And there we go, kind of pinched off again. The ridge holding hard off of California as we get into Monday. But the jet stream, all in all, well consolidated, very energetic, very different than what we saw a couple of weeks ago. Very much suggestive of the active phase of the MJO doing something. And we'll get more into that in a minute. Next, let's take a look at surface level pressure, surface level winds. As we expected, high pressure over the West Pacific, high pressure off the U.S. West Coast, some sort of a low trying to develop in the trough that's developing there. And here's our tropical system Lan just off of Japan, probably pushing over Tokyo right about now. Anyway, roll this out. Not a whole lot goes on. Lan's the major feature, heading northeast, recurving, starting to build 50 knot winds into Monday night, embedded in a broad area of 35 knot winds reaching the whole way from the Kuril Islands to the dateline. But notice a lot of this fetch is to the north. Not so interesting yet. But there, 6 hours later, boom. Good solid fetch of 45 knot west winds, little patch of 50 right under there, and building solidly to 50 knot winds. This is a full extratropical winter storm as of Tuesday morning, pretty far to the north, the core of the low or the storm over the Aleutian Islands, but all the fetch that we care about is south. That is good news. building to 55 knots, maybe even 60-knot winds there, near hurricane force, but not quite there. There again, come Tuesday night, 60-knot winds for sure, embedded in a broad area, 50-knot winds, south of the Aleutians, approaching the dateline from the west, continuing into Wednesday morning. Things start fading down. Good solid storm. Here is our cutoff low. Remember that trough that was right here? Just north of Hawaii, building some fetch, pushing at the islands. Another tropical system forecast in the West Pacific too. Anyway, extratropical storm land starts fading out, and then where are we? We're into Thursday now. Things start fading off. Tropical system, we're keeping our eyes here, but then this is probably the more immediate concern. Let's see what happens here. Not a whole lot, if anything. Notice this tropical system is supposed to be taking a track very similar to land's, and building then again at 180 hours out. Hard to believe, seems impossible. But in general, the outlook looks pretty bright. So let's take a look of the effect of those winds on the ocean surface. And as expected, Typhoon Lan, has the most impact, supposedly 54-foot seas. We'll check that out here in a minute. Anyway, otherwise, pretty static pattern, not a whole lot going on. We watched Lan take off to the northeast on Monday evening, not doing, looking okay, but it's not till Tuesday morning that things really start getting interesting. 37-foot seas building. We call this the north dateline region. There's the dateline. North is up here. The core dateline would be more down here. But north dateline region, there we go. With the winds building, 55-knot winds, 60-knot winds. Seas 46, 47 feet. 48 feet according to this right there. 18Z Tuesday, quickly building to 56 feet. That is quite high indeed, to 59, almost 60 feet on the dateline, 06Z on Wednesday. That is certainly something to get your attention. Long period swell would result from that, radiating into all this area. Then issues become questions of shadows, things like that. Still, 54, 55-foot seas Wednesday morning, dropping, falling southeast, 40-foot seas. And new system over here supposedly building with 53-foot seas. That seems a bit on the high side. Anyway, and our extratropical storm Lan is gone. That is just raw sea or raw swell energy moving away from the fetch area. And you can sort of see the track impacting sideband energy into Hawaii. The focus looks like the U.S. West Coast, for sure. Then we get into next weekend. Small system on the dateline again, 22-foot seas, nothing really of interest. Roll this out. Here we go. Watch the next system. See if it does anything. 180 hours, not looking too impressive. So, obviously, extratropical storm Lan is actually Typhoon Lan right now is the hope. It has not done anything. It is just a typhoon off of Japan. Still has 3 days to go before things get interesting, and we all know that the models are notoriously bad at forecasting tropical systems, and so there is much room for error. Don't believe anything the models tell you this far in advance. Not a breath of wind is producing swell of any significance for our forecast area at this point in time. And here's just a quick look at Lan. The official forecast track moved into Tokyo about midday today. Current forecast later on this evening, a couple hours from now, 90-knot winds. That's about what it's been. And then it goes down to a tropical storm status, 55-knot winds, but it also starts tapping the jet stream there, and that's what causes it to explode. There's already good circulation at the surface. Add in jet stream energy and pulling up warm moisture with cold air, and that would cause explosive growth, and we'll see whether that happens, but that's sort of the lay of the land. And just a real quick look back, what's happened, what swell is in the water, working its way towards our location. So we're on Monday night last week. This is the system that generated swell that is currently hitting California at this time. It's past its peak, of course, but just take a look. Up to 40-foot seas in the Gulf of Alaska, pretty far to the north. Makes more of a northerly angle swell. That sort of makes it harder to get into Southern California. Also shadowed in select places in Central California. But then another system developed right behind that. Let's go put that, whoops, right there. So Wednesday into Thursday, 34-foot seas pushing over the dateline up to 36-foot seas on Thursday morning, and then pushing across the dateline and fading in the western Gulf. What was that? It was 26-foot seas on Saturday. This swell is already starting to hit Hawaii. Nothing particularly large, and there, of course, is land. And where are we? There we go. That's the last small swell starting to hit the Hawaiian Islands. It'll build a little bit tomorrow, but nothing significant. And some of that energy is also supposed to reach the U.S. West Coast on Tuesday. Nothing particularly large, and it will be still remnants from the Gulf gale will be hitting, remnant swell energy will be hitting California. So it'll be two swells, both of them pretty much from a pretty northerly direction, like above 300 degrees. Certainly will make swell, and winds are supposed to turn offshore. So there could be some fun days of nothing huge surf, but, overhead surf and exposed breaks north of Point Conception. Next up, a quick look down south. Not a whole lot going on. We're just going to roll through this so you can see for yourself. You look for pretty much 30-foot seas. That's what it takes for any decent swell to make it intact up into California. And there we go, 180 hours. Nothing happened. But a week ago, two systems were of interest. One on the far southeast edge of the California swell window. I think we talked about this in our last week's forecast. Also another one pushing under New Zealand. Roll this out. What was that? 30 right there. 37-foot seas aim north. Swell is starting to hit Southern California. Not a bad little pulse of swell, too. Probably shoulder, head, high range, something like that. Another system tracked under New Zealand. Build tiny area, 40-foot seas. This one will be for sure be larger in that it pushed north and it's closer than being this far away. This is more like 5,000 miles versus 6,000 plus under New Zealand. But anyway, two little southern hemi swells in the water or working their way towards California. This one also will generate some right there, some tiny swell, most of the energy pushing off to the east, but also make for swell pushing up into Hawaii, up off the chart up in there, but nothing particularly large. The other issue for California from this south swell, yes, in Southern California areas facing due south will get some of it, but as more north swell builds in, that could sort of obscure it. Certainly in Central California and Northern California, you'll probably hardly even see the southern hemi swell, as the northwest swell from the Gulf of Alaska is much larger, and the secondary swell coming from over in the North Dateline region will also be much larger. Let's take a quick look long-term, what's going on with the MJO. And of course we know the MJO, when in the active phase, tends to excite the jet stream in the North Pacific and sometimes in the South Pacific, and helps to generate, of course, storms, and storms generate swells, etc., etc. And we'll also take a quick look at what's going on with El Nino and La Nina, but we'll tell you it's nothing particularly good. We'll start out our tour looking at winds in the Kelvin wave generation area. This is the West Pacific here, East Pacific here. That's the equator. That's New Guinea right there. It is this little area. We call it the Kelvin wave generation area, from 170 west, 5 degrees north and south of the equator, over to 135 east, right in here, this little patch. When winds turn westerly, or even when they die, that helps feed the jet stream. So this is actual wind speeds, you can see, and this is from the TAO buoy array, series of buoys strung across the equator. This is 5-day average winds from the east. The longer the arrows, the stronger the winds. Looks like it's pretty brisk trades right in that area, but not so brisk right over the Kelvin wave generation area. That is a good sign. We look at anomalies, differences from normal for this time of year, and we see, yeah, these winds are blowing hard. In fact, given that the arrows are pointing from the east, they're blowing harder than normal for this time of year. Easterly anomalies. But we get into the Kelvin wave generation area, and for months, for 6 months now, winds have been easterly anomalies. Now all of a sudden it's calm, and there's almost a hint of westerly anomalies. That is a sure sign, often, of the active phase of the MJO. Let's dig a little deeper. Let's look at the forecast. So this is the whole world, all globe on one planet, Kelvin wave generation area, right in between here. That's the date line right there, right in the middle of the chart. 180 degrees, 0, 360 on either side. Kelvin wave generation area right in between these two tick marks. Blues, purples suggest easterly anomalies. We've talked about this before. Persistent easterly anomalies since April or so. Really pretty strong though, starting in May time frame or so. And here you go. So the whole month of October, pretty much easterly anomalies. But look at this. Here's the forecast. Here's the, oops, here, we'll pull that down so you can see the Kelvin wave generation area right in there. Last little bit of easterly anomalies forecast to die, and then a hint of westerly anomalies for the next week. Another sign of the active phase of the MJO, and that would kind of make sense given what we once saw in the jet stream. Two, tropical system, a significant tropical system forecast to recurve and tap jet stream energy, and southern hemi activity. I mean, in the past couple of weeks, we've had more southern hemi swell than we had the whole core of summer. So all these are signs that something's going on with the jet stream, or with the MJO, helping to feed the jet stream, and in a good way. And more confirmation. We look at the outgoing long-wave radiation forecast charts. Blues mean less outgoing long-wave radiation. That means less sunlight reflectivity off the ocean's surface, meaning cloud cover, meaning low pressure, meaning the active phase of the MJO. And, of course, reds meaning more sunlight reflectivity, meaning the inactive phase of the MJO. So right now, per the statistical model, active phase of the MJO pretty much at its peak the next 5 days, and then starting to fade out, and 2 weeks out, it's gone. We look at the dynamic model, it pretty much says the exact same thing, whereas the statistic model suggests the inactive phase of the MJO might work its way into the West Pacific. This model, the dynamic model, says no, just going to dead neutral. That would be the preferred outcome. Phase diagram charts, another way to track what the MJO, the active phase of the MJO has done and what it will do. Okay? You're looking down on, let's say, the North Pole. The MJO runs from west to east, from the Indian Ocean over the maritime continent, Bali, over the dateline, over the West Pacific, under America, across the Atlantic, on the equator, on top of Africa, back to the Indian Ocean. The heavy dot right there is where the MJO is, active phase, so it's in the West Pacific. The further outside of this circle it is, anywhere out here, the stronger it is, the closer inside, the weaker it is. So, moderate strength, active phase of the MJO, forecast to track to the east the next 1, 2, 3, 4, 5, about a week or so, and then collapse in the West Pacific. This per the ECMF model, and we look at the GEFS model, GFS ensemble model, it says pretty much the same thing. So we got about a 5-day window where the MJO is going to really push the jet stream, and then things are probably going to get a little bit weaker after that. Upper level model, so here's Mexico, South America, there's Australia, New Guinea, Kelvin wave generation area right in here. Now this runs up probably about 2 weeks ahead of what really goes on at the surface, but it shows the greens are areas favorable precipitation, the reds not favorable. So this would suggest the active phase of the MJO working its way across the Pacific, moving into and on the equator into South America about the 8th of November. So that's about when the 6th of November. So that's when our, support for storm protection might start fading off. The inactive phase works its way into the West Pacific at that time, makes a pass the whole way across the Pacific through about Thanksgiving. And as we get, let's say the 20th, somewhere around Thanksgiving, another pretty decent active phase of the MJO is to wake up, and that would be when we get our next storm cycle. Maybe 3 to 4 weeks. The active phase takes about 3 to 4 weeks to make it across the Pacific, and when it does that journey across, it tends to support storm formation. So when it's over here, storm formation in the West Pacific, Central Pacific, and then if it gets like over here, more like the Eastern Pacific. Good news is our favorite model has been fixed and is up and running. We tried to decipher and pull some data out of it, but it was pretty much a mess for the past couple of weeks, but looking good now. Suggesting, so Kelvin wave generation area right in this area here. This is, again, the whole planet on one chart going this way. And so back in time is down at the bottom. The future is up here. October 22nd. So we can just overlay the MJO right there. There is the active phase of the MJO. Westerly anomalies are the yellows and oranges, and that's what we see going through about Halloween, a little bit past Halloween, 30th, let's say the first week in November. And then the inactive phase sets up pretty much like what we saw before. Blues are easterly anomalies, but notice this. A little bit of westerly anomalies, not too bad really, right in the core of the Kelvin wave generation area. And then it's not till we get into about Thanksgiving, just as we said, here comes the next active phase of the MJO. So the good news from all this is we have had no MJO activity, nothing for 6 months. And you'll say, why is that? And we'll get into that in a minute. But basically no MJO activity. But now we're starting to get, all back to the regular alternating active inactive phase. When you're in El Nino, you just have like a perpetual active phase of the MJO that goes for months and months. And then when you're in La Nina, you get what seems like just perpetual inactive phase of the MJO, and the active phases are very weak. Anyway, let's go take a look at the low pass filter. There's some other good news going on here, and we'll see if we can drag this down here just a little bit. There you go. Okay, so there's the Kelvin wave generation area right along in here. So this dotted contour is La Nina, the area, supportive of La Nina, pretty much. But notice it's slowly drifting off to the east. Not a lot, and this is El Nino supported activity, if you will, slowly drifting its way off to the east as well. And once you get into the late December time frame, say that the split point is right there, and if we can get this, which is just about, not quite out of the Kelvin wave generation area, but pretty close. What this means, though, is probably the underpinnings for La Nina will be substantially weakened as we get into the new year, but it'll probably take 3 months before you really, the atmosphere and the ocean are a big boat. It takes a long time to turn them. So let's say we reach over the threshold in January. It won't be till the end of April or something like end of March till you really start noticing anything. And by then, winter and spring are over and your season is lost. So for right now, the pattern clearly is La Nina favored, and we'll show you more of that in a minute. This chart shows you the strength of the active phase of the MJO. Historical context, back 2015 when we were in El Nino, big spikes of the active phase of the MJO. 2016, yes, still the same deal. We got into 2017, we still had a hangover activity from El Nino, even though officially we were in some sort of weak La Nina. And then in April, things just died, and you could see how weak the MJO was. And now, just now, the past week or two, see the spike upward? This is the building first legitimate or semi-legitimate active phase of the MJO since, end of March, something like that. So it's been a good long time. Good to see the MJO return. Next, let's take a look subsurface. What's going on in the ocean? We've talked about the MJO, we've talked about the atmosphere a little bit. So what's going on in the ocean? Is the ocean responding at all or giving us signs of what's going on? Clearly it is. Lots of warm water. There's actual surface water or subsurface water temperatures at depth. West Pacific here, East Pacific here. Buoy anchor lines on the TAO buoy array. The X's are the sensors on those anchor lines, and with that you can kind of get a sense of what's the profile of distribution of subsurface temperatures. Warmer, 29 degrees here in the far West Pacific. The warm pool displaced off to the west. Not much warmth in the east and very shallow indeed. How's that differ from normal for this time of year? Here's the anomalies. West Pacific, pretty much normal, not even above normal, just zero, dead neutral. But in the East Pacific, cooler than normal, 3 degrees below normal, down at about 120 west, down 100 meters. And this water, we believe, is advecting up to the surface, getting pulled up to the surface. Remember, we have strong east trades over here. That causes upwelling. It's tapping that cool water, sucking it up to the surface. We'll show you in a minute some more. Another model using the same raw data, and you can see it clearly. Look at the fingers of cool water radiating up to the surface from, 100 west out to 160 west. That's like just south of Hawaii. Cool pole, a big subsurface cool pool. Not really any significant warming over here. So it takes a couple of years after El Nino for trades to blow, and start building up a bolus of warm water here in the West Pacific. When it gets strong enough and just can't hold itself any longer, then trades collapse, warm water starts flowing to the east. But we're in the opposite of right now. Cool water in the east advecting to the surface. The trend over time, upper ocean heat anomalies, upper 300 meters of the ocean surface. A year ago in November, we were in some sort of weak La Nina. Let's say 2-3 shades of blue, and then somewhere in March last year we got this kind of El Nino pulse. It really wasn't El Nino, but weak Kelvin waves, Notice warming was over here in the West Pacific. Final discharge of El Nino moved all that warm water to the east, and now here we are, not really any warm water left over here. And this cool pull really doesn't look any worse than it did last year, but take our word for it. It is. It's much more pronounced. So this kind of washes out some of what's going on. And just one more bit of data here. Sea level anomalies. Strip out all the waves, strip out the wind swell, strip out the tides. Where is the ocean surface? Is it above or below normal? We see there's this big pocket here off of this South America right here, Ecuador, Peru, 10 centimeters below normal, one pocket of 15. So that suggests cool water at depth. Cool water at depth, of course, contracts or, and sort of causes a divot at the surface. So this is just another indicator that, in fact, there is a pretty large cool pool of water. And notice it's between 100 west. I'll pull it up just a little bit. 100 west and 160 west, just like what we saw in the other chart. So all this data sort of corroborates each other. So that's the subsurface profile. What's going on at the surface? Well, as one would expect, you can see here, warm anomalies off of Mexico, but the area that matters is right on the equator, off of Peru, upwelling blues. You can see those negative anomalies. So upwelling along Peru, classic sign of La Nina. And that upwelling just flows right over the Galapagos, solid right on out. What do we say, 100 out to 160, and you can see that much upwelling going on here. We know trades are strong. We know there's cool water at depth. We know, and with this, that suggests that that cool water is getting sucked to the surface and building a cool pool. Trend over the past 7 days, yeah, pockets of immediate cooling, mainly out around 120 to 160, but it is still quite cool along here. All this suggests is that it's not getting any cooler, maybe even slightly warmer right along Peru, but not warm, just pretty much steady state. Here's the chart that really indicates what's going on, whether El Nino or La Nina. You can just see cool water. This is sea surface temperature anomalies from October 21st. Pretty high resolution. Cooler than normal. We're not going to try to read the actual degrees off here. We got another way to do that here in a second. But cooler than normal off of all of South America, coming off the Galapagos, radiating right on the equator. The main area for monitoring El Nino, La Nina, Nino 3.4 region right here, 120 west to 170 west, 5 degrees north and south of the equator. Sure looks cooler than normal to us. Here's the sea surface temperature trend up along the Galapagos in Peru. You can see kind of steady downward right now, 1.1 degree below normal. That's all it takes. But this is a pretty noisy region. This is not the official area for monitoring El Nino, but this is sort of where its genesis starts. If you have a lot of strong winds here, the trades will carry cool waters in this region over into the main Nino 3.4 region. And here we go. Nino 3.4 index. This is from models basically, but you can see the trend steady since July, steady downward trend. Just draw a line right through that. Currently 1 degree below normal, 1.036. So that is indicative. If this were to continue and just hold in this region for the next couple of months, then that is a clear sign of La Nina. So what's going on in the atmosphere? Is the atmosphere responding to what's going on in the ocean? Now we sort of talk multiple things at the same time here. We talk the MJO, which is an atmospheric thing, but it sort of reinforces what's going on in the ocean, and then temperatures and winds affect the ocean. The ocean then starts changing itself, maybe getting like it is now colder on the equator, over, let's say, the central Pacific. That in turn then reinforces what goes on in the atmosphere. The two of them sort of feed off each other, and you get trends and until something goes so far to one extreme, then it flops the other way. Anyway, so Southern Oscillation Index, difference in pressure between Darwin and Tahiti. Positive numbers suggest over a long running period of time, suggest the inactive phase of the MJO, and it clearly has been positive for a long time. Notice just recently it's starting to go at least towards neutral. That would suggest the active phase of the MJO beating it down. The 30-day running average, a good way to get a sense of what's going on, getting just more and more positive, up to 13.2. That clearly is bordering on La Nina territory. Certainly the inactive phase of the MJO, now just this little bit of a dip has started to take a little edge off of that, but not much. Then the 90-day running average. This is your real way of looking at El Nino, La Nina. It is positive, and when you get into the positive 10 territory, then you're in pretty solid La Nina range. We're not there yet. In fact, it's backing off a little at 7.05 today. And then we look at the ESPI index, very much like the Southern Oscillation Index, but we're monitoring the area in that we're monitoring the area north of Darwin, Australia, and north of Tahiti, but we're looking at total precipitation anomalies. If you have a negative anomaly like minus 1.25, that means less precipitation than normal there. That typically means colder than normal water. Colder water means less evaporation. Less evaporation sets your index negative, and that sort of doesn't feed the jet stream. You know, your Kelvin wave generation area is right over in this area, somewhere straddling the two. Anyway, index minus 1.25. That's actually better than it was a couple days ago. It was down about minus 1.5 or so. The deepest it got so far in this current La Nina cycle this year was like minus 1.9 a couple months ago. So that's actually kind of a good sign in that it's mellowing out. Maybe the peak of La Nina has been reached and is backing off, or maybe just the active phase of the MJO has taken a chunk out of this thing for right now. It'll come back stronger as we get into the active phase, the inactive phase of the MJO, let's say a couple of weeks from now. And then finally, the forecast, CFS version 2 forecast for the Nina 3.4 region, sea surface temperature forecast. October, we are at minus 0.4. The forecast has it going down, but you know what? This is looking a bit better. We were down, it was suggesting temperatures down around minus 1.5. Now we're talking about 0.09, 0.9. 9/10 of a degree below normal. That's still La Nina territory, but not super strong La Nina territory. Certainly stronger than last year. And looking at all the other data, we definitely are in La Nina territory. But we have a little bit of MJO going on. Maybe that will help us. Now, this model, the CFS version 2, was the outlier, the coldest of all the other models. Most other models were suggesting somewhere between a half and maybe 0.7 of a degree below normal. This is still a little bit lower than everyone else, but it updates regularly, daily, so we like to watch it. Anyway, this year probably lost to La Nina. We knew that was coming. We had 2 years of El Nino. You pay the price. You always pay the price. So we're paying our price, but it's not that bad. If the MJO, which now appears to be waking up, we thought it was completely being squashed by La Nina, but if it can kind of just keep some regularity going from here on, at least there will be windows, 3-week windows where the jet stream will start pumping, storm production will increase. Maybe we'll get some rainfall into California. The jet will dip down. Probably more like backdoor sort of cold fronts coming north from the Pacific Northwest. Anyway, that in general, this is not as bad as it was looking a couple weeks ago. So to wrap things up, swell is in the water for California, not a whole lot for Hawaii, but there's new swell, small swell, starting to work its way into Hawaii, and that'll be there around for a day or two. And some of that will work its way into California as well starting Tuesday. Nothing huge, and that'll combine with existing swell that's still being moving out of the Gulf of Alaska, and with high pressure near overhead and offshore winds forecast, there'll be rideable surf. All eyes, of course, on the West Pacific and typhoon land. Will it turn extratropical? We don't know. Hopefully it will. That'll make some long period swell as well, but from a rather northerly direction again. But Hawaii should get some, and California should get some if all goes as expected. And of course, southern hemi swell in the mix for the balance of the work week, mainly for Southern California. So that's it. We'll do it again next week. Same time, same channel. Thanks for watching.